Hello and welcome to Through the Telescope, the podcast that puts the lens on astronomy. I'm Rose Waugh and I'm an astrophysicist and science communicator.
And I'm Elliott Bruce, and I'm neither of those things, but I'll be trying to find out why we should even care about astronomy. We'll be exploring some of the big topics in the field in little manageable pieces and have some fun along the way.
So, whether you know your red giants from your red shifts, or you're not quite sure what the difference between astronomy and astrology actually is, join us as we launch ourselves into the cosmos and try not to burn up on re-entry. Through the Telescope is sponsored by Pic Astro, the astronomy and astrophotography image sharing app, dedicated to your images of the cosmos no matter what stage you are on your journey around the universe. No ads, spam, or fake accounts.
So, Ro, before we start with today's episode on the Earth, we should mention we've got some new branding.
Yes, we have. Thanks to Tom for our epic new thumbnail.
So as well as being sponsored by Pic Astro app, Tom from Pic Astro app actually sorted out our graphical.
He took pity or embarrassment at us and gave us a really badass new thumbnail for our podcast. It feels like so cool. It makes me feel like I'm a cool person.
Yeah. Also, as somebody that listens to podcasts, I'm sorry to anybody who is mildly irritated by the change in branding, but also not sorry because the other one looks way worse.
Yes. I love the sci-fi feel of it. Like, it's a piece of art. I'm really impressed by it. So thank you, Tom. We really appreciate it. Making us seem like cooler people than we really are in real life.
Definitely. So with that, Ro, the Earth. We live on it.
We do. We're quite familiar with it.
Yeah.
Sometimes not as familiar as we maybe should be in the modern world. But
So it's one Earth mass.
yes, it is. And its radius is one Earth radius.
Which is actually half the radius, the diameter of the Earth too.
Oh, really?
Yeah.
That's a good fact there. A little factoid.
What I do find crazy is that it's not spherical.
Yes.
Not perfectly spherical.
It's not.
But that's not specifically Earth rated.
No, it's something that a lot of planets and stars experience. Their rotation means that they bulge at the midriff, as many of us do.
Yes.
Yeah, and because the Earth has a lot of water on its surface, it can be, more noticeable as well.
Sloshing about.
So it's not perfectly spherical, which is a bit weird. I guess we are used to it being depicted as a sphere, and so we then kind of absorb that, but technically not quite spherical.
So we are, we're not so much average as we're sort of Goldilocks, right? Well, literally in the Goldilocks zone, which I guess we'll maybe talk about later, but we're sort of, what are we? We're the fourth smallest and the fifth largest, and we're quite close, but not too close.
Yes. Well, so in our solar system, as our listeners have probably noticed, as you have probably noticed, the rocky planets are all, at the centre of the solar system. Or, relatively speaking, close to the sun. And further out are all the gas giants. That's worked out quite well for us on Earth, because it means we're, like you say, we're in the Goldilocks zone, which is a term that is thrown around a lot, and I have been, guilty of using it myself, but probably isn't actually that helpful because it's very Western centric. You have to know the story of Goldilocks and the Three Bears.
It's not even Western centric, it's kind of Anglo centric, because I assumed that Goldilocks and the Three Bears, like all good fairy tales, was German, and if not German, then Danish.
Is it not German?
No, it's British.
Oh, I also assumed it was German because it's a fairy tale.
Citation needed, but I think...
And it had bears in it, so I kind of thought, it's going to be like a Grimm's fairy tale where actually the bears eat Goldilocks or something. But...
Yeah, maybe that's the reason why it isn't a Grimm fairy tale. But yeah, so I first found this out from a Bulgarian postdoc in our group.
Yeah.
We were trying to say something was just right in a paper, and we said, it's like Goldilocks. And she's like, sorry, what's Goldilocks? I'm like, no. But no.
But no, she didn't know.
No.
Yeah.
So for anybody not knowledgeable about Goldilocks and the Three Bears...
which is probably quite a significant amount of our listeners, actually.
Yeah, there's like a little girl that has blonde hair that sort of breaks an entry into the house of three bears who aren't in at the time, who all have like three different sets of things, so like porridge and beds and chairs, and one of them is too like small, one's too big, and then one of them is just right. And so we are...
For Goldilocks.
For Goldilocks.
Yes.
Yeah. They're all right for each bear that likes it that way.
So the big bear likes the big chair and big bed and whatever.
Yeah.
And the small one likes the small items.
Yeah.
Etc. But yes. For
then,
Goldilocks, only the middle ones are just right. Whichever one.
Yeah. And then the bears come back and tear her apart.
Yeah, so that it doesn't happen, even though we both assumed that was what happened in the original. Interesting rendition of Goldilocks and the Three Bears. But yeah, the point is that it's often used as a term to say something is just right. And Earth happens to be at a distance from the sun that is considered just right. Specifically for liquid water to exist.
Yeah, and so then that's always talked about because it's seen to be important for life. Out of 8 planets in our solar system and more that we know of outside of our solar system, we're the only one that we know of with life. We've got close to 9 million species.
That's a lot.
It is. We've only seen just over 1 million. We just assumed the rest.
This is plants and animals, presumably.
Plants and animals. I guess maybe possibly also bacteria and archaea. I'm not entirely sure.
Maybe fungi.
I got it from National Geographic, so don't know. But, given that there are, 8 billion humans now? And there are more bacterial cells in your body than there are human cells.
Yeah, that one's not that weird.
No, but it's just, it's not just that Earth has life, it's got life coming out of the ears.
Yeah, so, it's riddled.
Riddled, infested. So, people always like to say, why do we have life? Why doesn't it exist everywhere? And as Jeff Goldblum says, life finds a way. So, why do we have life on Earth?
That question is asked quite often. Why do we have life on Earth? And I don't know. Maybe I'm just being grammatically sensitive. I don't know, but I always think surely what you're actually asking is how do we have life?
Fair.
Because I don't know why we have life. No one will ever know why life exists.
Yeah, because you could also say, why does the universe exist?
Yes.
And you're like, it does. People have their own reasons for that. You can speculate.
But it is often asked, in the form of, why do we have life? rather than how do we have life. Well, I guess the first question in response to that is, well, did it develop here or did it come here from
Panspermia.
somewhere else? But as you like to point out regularly, and I do feel the same way, it feels like kicking the can down the road.
Where did that life come from?
If it did come from somewhere else, where did that come from? How did that develop? There is a lot that we just probably do not know about life and how it came about into existence. Everything that we do know is very Earth-centric.
Yes.
Because we, like you said, there's a huge number of species of life on Earth. And there are loads of different environments in which life has found a way of surviving and thriving.
Yeah, there are some bacteria.
But they're all Earth-centric.
Yeah.
So, yeah, there are lots of speculations of, what I have heard called, and I quite like it, weird life.
Okay.
Where, all of the life as we know is carbon-based. But there's been lots of, speculation, ideas, I don't know how you'd want to word it, but that there could be like silicon-based life or something that could replace carbon to fill a similar role in the life form, but isn't carbon.
And the idea with silicon is that if you look at the periodic table, silicon is directly below carbon. So it likes to form 4 bonds to things in the same kind of geometry-ish. So in that way it's kind of attractive as like a potential stand-in for carbon. But as my old inorganic lecturer would say, carbon and its adjacents like oxygen and nitrogen are the bad boys on the block, and they don't behave like the other ones. But like you say, when you're out there in the crazy space-times, you got to think about weird things that could go on.
Yeah, different environments, and a lot of chemistry as we know it is also Earth-centric. A lot of the chemistry that we, that most chemists, including probably said lecturer, are very knowledgeable and expert in, is very Earth-centric chemistry. And it might not be that way on other planets. And so maybe there is weird life out there that is silicon-based or something else, or maybe, uses methane rather than water or whatever.
Yeah.
And we really know next to nothing about that.
Yeah. Which is why...
Because we have no information to go on.
That's part of the reason why we like... I think we talked in the previous episode why we like to go out and look for different types of life. So when we talked about Venus, just because having any more information about other environments where life has developed can give us an idea of what you need and what is sort of optional, as it were.
Because, right now what we do know about life, which is, in some ways quite a lot, it's all from what we know here on Earth.
And that's developed over such a long time, and it's now so diverse, and the environments of the past would have been very different and also very similar, presumably, at different points. And it's just complex, to say the least.
Very, very complex. But, we can work on the principles that what we know about life here on Earth can tell us about what life might need. We can't constrain it to that alone, because there might be weird life. But we can say a reasonable amount about what we know from, not weird life.
Yeah.
If you know what I mean. Like
More
it's not,
typical life.
Yeah, it's not a technical term in any way, and I wouldn't like it to be one, because it feels weird to be like, where normal, anything else is not normal.
Yeah.
That's like, I don't know.
I
don't really
also-
like that mentality, but
It's weird on a different level, because at the same time, like, other things are weird, like bacteria that can eat plastic, for
yes.
instance, or just giraffes. Like, have you
Yeah.
seen their necks? Like, that's pretty weird.
Pretty
Like-
weird. Really weird, actually, but
Or okapis that can lick out their own ears with their tongue. So, go figure.
life goals.
I know, right? But
Yeah, so what we know from Earth, variables that we know about that could be important for life's development would be a planet that supports liquid water.
okay.
We know for our life forms on Earth, liquid water is incredibly important. So, as we said, that could be described as a planet being in the habitable zone or the Goldilocks zone, which basically means that it's far enough away and close enough at the same time to the star that it is at the right temperature and pressure for water to exist in a liquid form. So there's a range of orbits where that can happen, and that depends on the type of star that you have as to how hot it is, basically.
Right, yeah. Yeah, so if it's more active, is that a bad word? If it's more luminous, is it hotter?
Mm-hmm.
Then
It's hotter.
you need to be further away. If it's a colder star, you need to be closer.
Yes.
But I guess you also don't want it to just like obliterate your atmosphere,
Yes.
for instance.
So, when you get closer to a star, you gain other issues that, maybe now you can support liquid water, great job, but also some of the stellar activity that we talked about in one of the sun episodes. And if you've got, lots of flares going off, if you've got prominences being ejected, if you've got lots of eruptions, from the surface of the star, that is more likely to cause you an issue if you are closer to the star. More likely to have impacts with that material and those particles.
Yeah. And I guess also when you get it as well, it's not sort of, we talked before, a bit like when you blow into a balloon and it expands with like the light coming from the star. It gets weaker per area as you get further
it gets
out.
more diluted.
In the same way, like if you're right up close and something does hit you, it's going to be worse than the same thing hitting you however far away, because it should hopefully have spread itself out a bit.
Yeah, it's not being diluted if you are closer.
Yeah. And I guess you don't want your planet just being sterilised by X-rays or something every however often.
Not going to be great for life,
Probably
typically.
not.
And then the atmosphere of the planet is also important. If you have a really thick atmosphere and it's got a lot of carbon dioxide and stuff, then that will influence where you need to be to maintain the right temperature.
Right, yeah. Yeah. Because that then starts to... when you think about the sort of the heat of the star, you're talking about energy in, but the atmosphere kind of helps mediate the heat in, but also the heat out.
Yes.
So you kind of...
So if you have an atmosphere that is really thick and kind of like a greenhouse, it collects all of the heat in and it doesn't let it out very quickly. So you don't then want to be too close to the star because
you just trap everything.
Whilst a planet with a thinner atmosphere might find that the right place for liquid water, it might, for you, then be too hot and you would lose your liquid
water vapour or
water. So, as we mentioned, the term Goldilocks zone has issues in that it's maybe not the most obvious to a lot of people what it means. The term habitable zone, which is another name for the Goldilocks zone also has problems, because it kind of implies a planet there would be habitable, but that's not the only thing that you need for habitability.
Right, yes.
So-
Also, is that then like habitable for humans? Because I feel like when we talk about habitability, we talk about we could go and live there. Do you know what I mean?
Yeah, so again, another reason why the term is not really very helpful is that different people bring different things to the word
yeah.
habitable.
What about happy medium zone?
Yeah, I don't know. Liquid water zone.
Liquid water zone.
I don't know. I'm sure the exoplanet community will say there is a different name for this that makes more sense.
Yeah.
But I am yet to hear it. So
Let us know. Or if you've got any suggestions, then write in, tell us.
And we have no power to change it in the scientific
No.
community, but
No.
I suppose I could use that in future papers.
You can start
I guess.
a trend.
Interestingly, slight tangent from this, that's
I
not
love
the
tangents.
only way that you could have liquid water. It's kind of always quoted as the way to have liquid
Yes.
water
The easy, conventional
in
way.
your system,
Mm.
but you could have, a different situation in which your planet, or maybe moon,
Mm.
is heated, and that allows you to maintain liquid water. For example, Jupiter's moon Io
Mhm.
is pretty close to Jupiter, and because of this and how huge Jupiter is and the gravitational effects, Io experiences a tidal force.
Io's the volcanic one.
Yes, the volcanic one.
Yeah.
Highly volcanic. This basically means that as it's, going around one bit of the moon, it experiences more gravitational pull than a different bit of the moon.
Yeah, the bit closer to Jupiter is
Yeah.
pulled in more than the bit further out,
Yeah.
that are facing away from Jupiter.
And this causes a squeezing of the moon. Like a stretching and squeezing, if you know
Yes.
what I mean. And that is like an energy transfer. It's adding energy to the moon,
Yeah,
and it's heating it.
yeah.
And this has allowed Io to maintain a liquid
Core
core
like
of some
volcanism.
form, and that's
sort of
allowed
thing.
it to remain volcanic, even though it otherwise wouldn't have, because it's probably not big enough to have done that.
And that's
otherwise.
also, is it Europa that they talk about as having potentially liquid water underneath the surface? So Earth has liquid water. That's good. We've got an atmosphere.
Yeah.
That's good.
Yeah.
I'm glad we've got an atmosphere.
Not only do we have an atmosphere, but we have a breathable atmosphere.
Okay. Well, what does
So
breathable mean?
that's a great question.
Thank you.
I feel like I'm talking to the kid again.
You do kind of act the same way to us, so don't worry.
Well, you both ask good questions. What it means really depends on the life form that you care about.
Okay.
So for Earth, that means that it's, relatively speaking, it's CO2 and oxygen rich.
Right, because like plants like CO2 will be like oxygen.
Yeah.
And there's also, I can't even remember what they're called, but ages ago there was the spongy things. Some of the
Yeah.
first things on the beach. Is it? Oh, I can't remember what they're called. Stromatopods or something.
Yeah, I think
Just
it was
made that.
carbon dioxide for them too, wasn't it?
Yeah, and then they
made so much oxygen that they basically killed themselves.
Yeah. Idiots.
Basically, well, they're going, but the other way around.
They're going to make a comeback. Yeah. Which I found crazy. Like, I only learned about that relatively recently. Just the idea that the atmosphere of the Earth wasn't always the same as it is now. You know?
Yeah.
And at different points, the dragonflies that are like the size of
Huge ones.
Yeah, like meters, like a couple of meters big, like crazy.
I think we just, again, it's like we've said this with lots of stuff in the podcast, we just get really used to our really specific little life.
Yes.
And that's something that astronomy is really fantastic for, is just like blowing your mind wide open
Yeah.
quite a lot and being like, look, that's just like a drop in the ocean. There are so many possibilities. It has not always been like that. It will not always be like that. You know.
Yeah.
Yeah, I think the thing for me that's crazy about the change in the atmosphere and the dragonflies and the massive insects is, you know, when you first think of it, you think of just like the composition has changed,
Yeah.
you know? But actually, it's just stuff like, well, that changes the density of the air. That's what starts to blow my mind.
Right, yeah, so then you require different things to fly, as
Yeah.
it were, because, yeah. Yeah, because I think, was that when it was oxygen rich? So the thing I'd heard was that the way that they breathe is it sort of goes over their skin. Is that right?
Interesting.
I could have made that up, citation needed. But so then when there was more oxygen, it, like, you could support a larger thing because sort of, I guess, surface area, volume, ratio, more oxygen, easier to breathe, and then when the oxygen level decreased, you couldn't support that size anymore, so they shrank.
Wow. Life will find a way.
Life will find a way. But pretty scary. I'm glad that we don't have them flying around now.
Yeah, I quite like insects, but I think my sister would absolutely freak her pants off.
Yeah, definitely.
So yeah, atmosphere is important, and I think, as we've mentioned before, it also protects us and life on Earth from the sun and some of the radiation, and also the cosmic radiation from, you know, other bits of the universe as well. And we can assume that that is also important for life elsewhere too. You know, high energy radiation coming at life of any form is probably not great.
Yeah.
So, tides as well, the tides of the ocean,
Okay.
thought to be important for helping life to have developed on Earth. It's a really good mixing pot, a way of mixing lots of chemicals together.
Yeah. Yeah. So you don't just end up with like a really dense bit of one sort of chemical in one area and it never mixes with other things.
Yeah. There's been some work done by someone in Oxford. I'm sure there's lots of work done by people in Oxford, but
There are lots of people in Oxford.
that suggests that eclipses could be an important indicator of which planets could have life.
Okay.
You know, looking out at exoplanets in the universe. Because it means that the moon is a certain size relative to the planet.
Right, okay. So it's sort of like, it's either really big and further away, or it's quite small but like close enough to the planet that you'd expect it to have a big sort of effect on tides. Is that kind of the idea?
Yeah.
Okay.
Which I just thought was a neat idea.
I think it's also crazy, like, I find it weird that we can actually see planet, especially the ones where we can actually just look at it with a camera. But I find it weird that we can detect exoplanets in the first place. And I am vaguely aware that there are exomoons that we've seen, but the idea that you could even think about seeing if we could have an eclipsing moon, you know, we're now talking about 3 celestial bodies in a different part of space, which are all progressively smaller, and how they go around each other.
Yeah.
Like,
so,
pretty crazy.
You know, this work and this idea is more theoretical, suggesting that, you know, you could use that as an indicator of whether or not life might be on the planet. Obviously, as we've said before, for something to be habitable, there's a whole range of conditions, like a crazy number of conditions that you need to meet. So it's not like a guarantee or anything.
Yeah.
But it is really fascinating. And it doesn't feel, which is wild, like you say, it doesn't feel like it's really going to be that long before we might be able to actually see these things and be like, we've seen a system where we have seen the planet and we've seen the moon, and relatively speaking, an eclipse, a total eclipse could happen there because we know their relative sizes and we know their distance from the star.
We know how they
we're
all go
actually getting to the
round.
point where we could start to collect data on that,
Oh.
you know, and it's amazing how far we've come in terms of exoplanets and observing them in a relatively short time period, really. But yeah, pretty cool. But going back to Earth and how or why
Yes.
we have life, you know, there's so many conditions, but we have talked about a few, so I'll only add one more. And obviously I'm ending with this because I'm a sucker for a magnetic field. But the magnetic field of the Earth is incredibly important to
You
us.
always manage to bring it back to magnetic fields. If it's not angular momentum, the answer is magnets. That's...
Yeah.
Yeah.
I'll let you in on a secret. I actually am a bit scared of angular momentum.
Oh, I hate angular
I
momentum.
still don't feel like I
Momentum, fine.
fully
Angular.
grasp the concept. It's too much verging on forces for me.
Yeah, I don't mind forces. Forces
Yeah,
are fine.
I know.
It's just, for me, rotation, I think when we started to learn about rotational mechanics, it was, oh, this is a bit different. Oh, no, it's fine, I get it. And then it just keeps on throwing up weird things, and the thing is always angular momentum.
Yeah.
But
Yeah.
anyone at home that likes angular momentum, good for you.
Yeah, we're not going to get many responses to that one, I can tell you right now.
I might get some. I don't know.
Magnetic fields, on the other hand, are beautiful.
Okay. Which also not many people say. Is that true?
Yeah, it is the way to be cruel to a lot of people at a conference after their talk, is to say, have you thought about magnetic fields? Yeah. But Earth's magnetic field is important. It helps us maintain our atmosphere.
Good, we need that.
So magnetic fields confine the movement of charged particles. Our atmosphere has, quite a lot of charged particles.
Yeah, anything in the atmosphere starts to go a bit weird in terms of chemistry. So
Yeah.
there's charged things, there's radicals, there's all sorts going on up there.
Yeah. Different environment.
We like to think the atmosphere is oxygen, nitrogen, or rather nitrogen, oxygen, bit of argon and carbon dioxide, but actually it's all weird at different points. So.
Yeah. And thanks to our magnetic field, we get to keep hold of it. And also the magnetic field helps protect us from the solar radiation that we talked about.
Yeah.
And in the meantime creates beautiful aurora for us as well.
And so I guess we then need like a molten metallic core, which then generates a magnetic field.
Yeah, because the interior of our planet is still liquid in various forms. The particles within it, including, iron and other metals, move about.
And moving charges
make magnetic fields.
And magnetic fields change the movement of charged particles.
Yes.
Yeah.
Yes.
Electromagnetism. But
Yes.
it's kind of neat, and then you look at equations, and then you're like, maybe not.
It's still neat. It's beautiful. Yeah. So because we have that liquid, used loosely as a term, liquid center,
Fluid.
we have our magnetic field still. And if you look at other planets that haven't quite been big enough for the gravitational effects of that planet to keep its core liquid, to keep it under such pressures that it stays liquid and it instead solidifies, like Mars, for example, the planet that might have had a magnetic field then loses it, because as soon as your core solidifies, you no longer have the moving charges, so you no longer have a magnetic field, so you no longer have an atmosphere, and it all goes to pot quite quickly.
Yeah. But the more important thing about magnetic fields is it makes pretty lights in the sky.
Yeah.
So, there's that too. Like, what's the point in life if you can't go, ooh?
Yeah. Yeah, they're incredible things, the Aurorae.
Yeah.
Yeah.
The Aurora Borealis and Australis.
Indeed.
Yeah.
The charged particles from our sun are channeled along our magnetic field lines, the magnetic field of the Earth, and because they're charged, so they have to travel along the magnetic field.
It's sort of, well, it's not spiral, it helixes round, right?
Yes. They have to travel along magnetic field lines, so probably everyone listening to this in high school science class or something was shown a bar magnet, and then there were, iron filings on the table.
Yeah.
And then you got that kind of pretty picture, I don't know, of the iron filings lining up to make these loops around your bar magnet.
Yeah.
If not, you can literally go onto Google and type in bar magnet iron filings, and it will come up. And basically, we can describe that as saying that iron filings are tracing out the field lines of the bar magnet. And you would get a similar kind of thing for Earth, of the kind of two lobes.
Yeah.
And two poles where the magnetic field lines are just kind of going straight up.
Yeah, which happen to align closely-ish with the rotational poles.
Yes, closely-ish.
Closely-ish.
Yes. So that's how the planet has technically two North Poles, because it has the North Pole, which is rotational, and it has the magnetic North Pole.
Which your compass points to.
Yes.
Unless maybe you use your phone one, which might just work out from a map, maybe. I don't know.
I've never thought about that. That's really interesting.
Yeah. Although it doesn't really matter that much, because once you get close to the North or South Pole, your magnetic compass starts to not really work anymore.
Yeah.
So.
Oh, that's interesting, though. I've never thought about the phone. So the charged particles from the sun are then being channeled along these field lines to the poles. And when it gets there, it interacts with our atmosphere.
Yes. And then chemical reactions happen.
Exactly. And our sun is constantly throwing out material. We're pretty used to that. But sometimes there are solar storms, are things like coronal mass ejections, prominence eruptions, flares, general activity, especially CMEs, and it chucks out lots of material. And because there's a lot, it becomes very noticeable that there's a lot of material interacting with that atmosphere. And this is what makes the northern and southern lights. So you typically see quite a few colours.
Yeah, you get sort of like your greens and your blues and your pinks, right?
Yeah.
Pink, red?
Pinky reds, yeah. Probably what you would see is going to be not as good as what you would see with a camera.
Right, yeah.
A camera is a lot better at picking up all of the photons and the light show than your eyes are.
Yeah.
So what you see isn't quite what you're sold on the internet, but is still, spectacular and magical. So the particles interact with the atmosphere, with the ions and the charged elements, if you like. And this causes them to emit light.
Yeah, so they'll have...
Makes them glow.
They'll have electrons that give an extra energy, and then when the electrons around the atom drop that energy comes out as light.
Yeah.
And the amount of energy that it drops corresponds to the colour, vaguely.
Yeah.
So.
Yeah. So for oxygen, that gives you the greens and the reds, and for the nitrogen, you get the blues and the purples.
Nice.
So that's mostly the colours that you're going to see.
Makes you think if we had a different atmosphere, then we'd have different colours.
Yes.
It's kind of neat.
Yeah. And maybe we can put in some requests for different coloured aurora, and you can tell me what kind of atmosphere my planet would need to have.
Yeah, it's worth
Or
thinking
maybe I can, tell you the composition of things like Jupiter and Saturn, and you can revisit that. You can tell me what their aurora would look like.
It sounds like homework. So, what have we got? We've got water, we've got atmosphere, we've got magnetic fields.
Yeah.
I guess we've got a mix of land and water as well, which you talked about previously being important.
Yeah, I mean, depending on the kind of life that you would want, I mean, for Earth, that we have done spectacularly well.
Mm-hmm.
It's a rocky planet, it's got liquid water, it's got oceans.
Yeah.
It's, got an atmosphere that is great in so many ways, and that's allowed for life to develop, in a huge variety on Earth. We've all the way from, microbes, but then once you get to more macroscopic life, we've got things that swim in the sea, we've got things that live on land, we've got things that can fly. There's a huge amount of variety.
Yeah.
Because of that, the number of environments that Earth has.
Yeah, and that's all
life.
the sort of macroscopic stuff, and then on the microscopic level, there's even more variety that we can't really comprehend.
Yeah. But there are lots of moons or planets where you maybe don't have the same variety for kind of macroscopic life, because it's, an ocean world or something like that.
Yeah. I remember reading, I think it's called Life Ascending, which is talking about different aspects of evolution, and talked about different theories of, and histories of the theories of evolution, which is in and of itself related to xenobiology, right? Because that's all, like you're saying, based on evolution on Earth, basically, and the origin of life on Earth, which we're not entirely sure about.
No.
Right?
Far from.
The current theory, hydrothermal vents at the bottom of the sea in different places.
Yeah.
And it's sort of like hot water comes out of these due to the action of, geothermal processes. And one thing that I found neat there was that they were saying that these vents have like little pockets that are about the size of a cell. So they were thinking that maybe sort of a bunch of chemicals happen to sort of coagulate in these sort of cells, and maybe the first life form didn't really have a cell, and then at some point this concoction of chemicals then
got some sort of skin, if
got
you like.
a kind of skin, and then etc. etc. But it's just like, it's so far back that it's kind of crazy. But we kind of think you need RNA or DNA, right? And then people talk about whether we do really need that, or whether it could assemble in something different.
Yeah. Yeah, it's reminding me of my current audiobook.
All right.
Which is called Alien Worlds. I can't remember the guy's name. But he, I believe, now works at the Jet Propulsion Lab.
Nice.
NASA. Yeah, it's quite interesting. Talking about that kind of thing. I think that he maybe was in a Netflix documentary or
I remember there was a
something before
Netflix...
the book. It's a relatively new book. So I don't know, maybe some of our listeners have listened or watched it.
Given our
I
last
haven't
episode,
seen it. But...
our last episode where we talked about sort of when you can sort of show things, sort of, what's the word? Artistic representations of things
Yes.
and public outreach. We did see an episode of something which I think is called Alien Worlds on Netflix, which was really weird because I'm sure it was like, this is a planet here which does exist.
Yes.
And
yes, it was.
these are the properties that we know of, so maybe it has like this sort of terrain if there was life here. And then they just like made up random things,
And then
including
they made
like
up random animals.
Yeah, and they were like, these are life cycles that could exist. And it was interesting because they were showing like through the form of, we've made up these different animals and they have this particular food chain and things. They then explained or compared it to stuff that exists on Earth, which I guess is kind of what we're doing here, right? We've got an episode about Earth and then ended up looking at outside of Earth.
Well, it is an astronomy / astrophysics podcast. We gotta make sure there's some space link, even though geoscience definitely counts as space to me. But.
Yeah, but I thought it was very interesting as an idea, and I did really like. I felt like it taught me a lot about sort of ecosystems and life processes on Earth. We only watched one episode. But it was also like, I'm pretty sure maybe we watched two.
We need to revisit that.
But yeah, and it also included a lot of this kind of conjecture of like, well, what if there was something that could make hydrogen? We know some things that can make hydrogen, so what if it used hydrogen in this way or something? Yeah. So,
I felt like the idea was really good, but I did feel like the execution was a bit poor.
It was a bit weird because it was kind of mixing fact and fiction.
Yes, I think that was my issue with it, was that it felt like it was not keeping in the forefront, that it was mixing fact and fiction.
Yeah, I know what you mean.
But yes, that was a weird program.
Going back to water. Where did it come from? Why have we got so much?
Yes.
Because I saw a thing recently, again, thanks to the kid.
Yeah. Was it also Kids Learning Tube?
I don't know.
I think we're addicted to that YouTube channel right now.
Anyway.
And that's just me.
It was it Pluto or Europa? Possibly both, or Ganymede. Some things out there in the darkest reaches of space. There are things that have more water than all of Earth's oceans combined.
Yes. Yeah, so Pluto has more.
Right, okay.
I don't off the top of my head know about which moons do, but yeah.
They got a lot of water anyway.
They exist.
I think, again, part of it is that the Earth is mostly like rock.
Yeah.
And it's just water on the surface.
It's surface water, yeah.
Whereas these have, like, depths of water.
I mean, for Pluto, it's frozen solid, right?
Right,
so it's not like liquid water, but even then...
It's not very close to the Goldilocks zone.
No. Even then, to me, at like 40 AU, it's pretty far away.
Cool.
But even then, to me, I find that wild.
Yeah.
Because we associate water with Earth, but actually it's really not.
Yeah.
It's really not like that. It is a great question. Why do we have so much surface water? Why do we seem to have so much when our planet is very rocky as well? You know, it's like we have quite a lot of water, but then our planet is all rock the rest of the way down. You know. It is true, other planets in our solar system are not watery worlds like the Earth is. I use the word watery worlds slightly hesitantly, but it is watery, if you know what I mean.
Wet.
It's wet, it's soggy, especially when you live in Scotland.
Yeah.
We don't fully know the answer, as with many things in science and astronomy.
We just speculate with evidence.
Yes.
Yeah.
I personally suspect that the answer involves a few different mechanisms.
Right, and some of those will be more important than others, presumably.
Yes. But possibilities could include that some of the water formed from the hydrogen that Earth had when it formed. Some could have been delivered to Earth by impacts of icy, planetesimals and comet-type things that are similar in composition to the asteroids that are in the asteroid belt.
Yeah.
Because they're left over from planet formation time periods.
Yeah.
Some could have then been delivered later during the late heavy bombardment of planet Earth, when loads and loads and loads of asteroids collided with Earth, which is, kind of a step in the formation of the solar system. And they could have brought a lot of water with them when they did that. Another idea is that it might have, or at least some of it might have, been brought to Earth during the collision that formed our moon. So Earth had a big collision in its past that we think could have been how the moon formed, and perhaps some of the material that ended up not falling into the moon but instead ended up as part of Earth could have had some or all of the water that we now have. But saying that, the measurements of the chemical composition of the moon, of the lunar samples that were collected from the Apollo 15 and 17 missions, suggest that water was already present on Earth before the moon was formed. So that, kind of contradicts that idea. But yeah, some scientists have suggested that Theia, which is the name for the planet that is thought to have collided with Earth and been responsible for the formation of the moon, could have come from further out in the solar system.
Okay, so there may be more icy like Pluto, but not Pluto.
Yeah, exactly, where it's more able to have formed into a planet that had ice, unlike Earth, which is much closer to the sun, and therefore less able to form into a planet that contains water.
And comets are icy as well, right? And they come from outside. So outside sounds bad. That sounds like outside of the solar system, but on the edge of the solar system, right?
Yeah, the Kuiper Belt objects as well. Pluto and
all
its
the things
friends.
Around the rim.
Lots of water, because it's able to form into ice there without getting just frazzled away, being closer to the sun. Anything else that you want to
Well, I think
talk about?
Earth is a weird one. Earth is something that we know a lot about, and there's also stuff that we really don't know about. Like, what is it? Like, we know more about the surface of the moon than we do about the depth of our oceans, which, we can see the surface of the moon relatively easily, so I'm not that surprised.
So that's not that surprising.
But
and we've seen the back of it now. So.
Yeah, so much stuff is available for us to study. It's so diverse in terms of its geology, its geography, its ecology, everything. And then you've got people which have their own set of weird things going on.
Yeah.
So it's kind of a bit weird as a topic to discuss.
There's so much that you could say.
Yeah. What's your favourite part of Earth? Is there like a particular location that you really like? Or...
Wow, you're putting me on the spot there. Yeah.
Was there anywhere you particularly like to go? Maybe from a more geography point of view than from a sort of cultural point of view.
Right, okay. Well, I've always wanted to go to Yellowstone
Okay,
National
yeah.
Park.
Yeah.
From a geographical point of view. Maybe one day I might do that, maybe. Yeah, I don't know really. I mean, I think there's so many different environments that I would like to see, both
Yeah.
from a kind of geological point of view and
Yeah.
also from the natural, like, fauna and flora,
Yeah.
if you know what I mean. I'm not really that interested in going to the depths of the ocean,
No.
personally.
No.
Like,
I'm also not particularly interested in going to
I'm
the height of a
fascinated
mountain.
by it.
Yeah.
And I would definitely love to just sit and watch loads of, I don't know, Planet Earth style
Yeah.
documentaries about the depths of the ocean and everything, but I don't really want to go myself, you know what I mean? Not actually interested in going into the depths of the ocean, so not that, but land-wise, I don't know, there's just so many different environments, and it's interesting when you go to a different country, or just even within the same country, you can end up in very different, natural environments.
Yeah.
Just how alien it can feel. It can feel really quite alien. Just the geology is different, and the trees are different, and I don't know, I think sometimes we take it for granted, kind of. But actually, if you stop to actually just look around you, it can feel really quite unnerving and alien, because it's very different. There is a lot of variety on planet Earth, which is beautiful.
Yeah, I think there's also a lot of variety that exists locally, so like the difference between like a coastal, a sort of marshy, a meadowy, a foresty, and different types of forests, and they all have their different characters and things, and then mountains, etc. And if you went to any particular location on Earth, there are going to be, obviously there are some bits where it's like quite a lot, it's very similar, but there's going to be, like, as well as the difference between what you're used to and that alien location, there's also going to be differences between local bits in that spot.
Yeah. I'm a bit of a sucker for a mountain. So anywhere that's got mountains, I'm more kind of drawn to. Not really that drawn to kind of a desert style environment.
Yeah. I'm not that drawn. I quite like mountains, but I'd also not really like to walk up a mountain.
Fair.
So,
Yeah. Where would be your place you'd like to?
I would say fjords.
Nice.
You get to see mountains. You don't have to climb up them if you don't want to.
Yes.
Yeah, I think they're nice. You might also be able to see an aurora there. I think New Zealand is quite famous for having lots of amazing things. I think there's lots of places that just have... I mean, like, relatively recently I went to Spain, which, for the first time, and, just the difference between Spain and the UK in terms of everything, really, just, like, geographic-wise, like... the sunsets look different, for instance, but like the sight, the sound, the smell, everything was very different.
It's funny how different places smell different.
Yeah, and so I think anywhere really. anywhere that's a bit different. But even if it's not that different, it still is, generally. So, also, maybe, I don't know, I think also some of, like, New England with its sort of autumny, foresty areas, sort of like a Stephen King novel. But I don't want to be in a Stephen King novel. I don't want to get attacked by an axe or anything.
Fair.
Or a creepy clown.
Yeah.
But,
Blue Mountains in China.
yeah.
Yeah, that would be epic
I love
to see. Absolutely epic.
That's something else. Is like, you think you know what a mountain looks like in Europe, right? And then you see mountains in Chinese art, and it's just like so different. And I guess it's what they're made of, maybe their age. But sort of more rounded mountains versus pointy mountains.
Yeah.
Which obviously, like, Mount Everest is pretty pointy. And also in China and Nepal. So.
Mountains of the solar system. That could be a good episode in the future.
Yeah. But there's a lot out there.
Yeah. I think the Earth is a similar thing to exoplanets that the sun is to stellar physics. That, like you say, there's so much data we just almost do not know what to do with it. It's you find yourself in the problem that every PhD student experiences, and I think anyone who is in depth learning about anything that they're fascinated in, whether that's for a job or a hobby or whatever, experiences, which is the more you learn about something, the more you realise you do not know or understand anything.
I reckon...
you start off thinking, oh yeah, like I know quite a lot about this topic, and then your confidence decreases very sharply as you realise
No, I don't.
Your mind is opened to how much knowledge there is, how much knowledge there currently isn't, because there are so many unanswered questions and everything, and you realise you don't know anything. Even though you know a lot about something, you just don't know anything, and Earth feels like that to planetary science, that we have so much data, we don't know what to do with it. It just makes more questions about everything. You ask one question, you get the answer, but then you get 10 more questions out of it.
Yeah, and I think also anybody doing sort of astrobiology, xenobiology would probably be quite happy if they had 5 planets with one species on it. It would be easier than one planet with 9 million, maybe. It'd just be like 5 different ways that life evolved. Even then, there'd probably be things that would disagree, but probably have more of an idea of how life came about than on this one planet.
Yes. I don't envy the people working to answer that question.
Yeah.
But I look forward to the answer when we eventually get one.
There's a lot to then speculate about and hypothesise about and disprove.
Well, with that, I think we should let our listeners go and appreciate the beautiful planet that they live on.
Yeah.
And maybe they can let us know if there's anywhere in particular they would like to visit,
or if there's a bit of Earth that you particularly like that's not necessarily like a place. It could be a thing, like daffodils. I don't know.
All right, Wordsworth. With that, have a good day. And we'll see you next week.
Bye. So that just about wraps things up for this episode. Please, can we encourage you to subscribe to Through the Telescope wherever you find your podcasts, and, if you like, you can leave us a nice positive review as well. It really helps the show, and it makes it easier for more people to find us.
Feel free to send us any comments, questions, or suggestions of things or people you'd like to hear about or from in future episodes. Or perhaps to put yourself forward to chat about your own astro research or experiences. As always, you can find us on Instagram at Through the Telescope Podcast, or you can find me at astrophysicist_Rose. You can also find us on Twitter at The Telescope Pod, and you can contact us by email at throughthetelescopepodcast@gmail.com.
And with that, we'd like to thank you very much for listening, and we look forward to seeing you again next time.
Bye.
Bye.